In the last class, we ended the discussion over bases that bases are compounds which are metal oxides, metal hydroxides, and aqueous ammonia. Out of these, the one which are water soluble are also called alkali along with the base, and the ones which are not water soluble are only base. For example, we have two examples. One is a metal oxide, copper oxide, and other one is a sodium hydroxide. So copper oxide, on adding water and when it is shaked, it didn't dissolve, which means it's just a base. But when we added water to a sodium hydroxide and shaked it, it dissolves. It indicates that it is a base as well as an alkali. Is this clear to all of you? Yes. That's where we have ended the last class. Okay, now this is the universal indicator chart, which basically tells us that how we can figure out between acid and base, and further how we can figure out between if the acid is there, then it's either a weak acid or a strong one. And in the same way, if there is a base, so it's strong or weak. So you have to remember these colors along with these things. So how do you do it? You have to note it down that under the heading of universal indicator, when it's very acidic, okay, then the color would be red. When it's slightly acidic, mention its color as a yellow. When the solution turns neutral, it is green. When it is slightly alkaline, then it's blue. And when it's very alkaline, mention it a violet or black.
So alkaline means
no, not black, violet or purple. Yeah.
Alkaline means a base.
A strong base. Okay, so I'm mentioning the color over here. Just note this table over here. Very acidic is red. Assalamu alaikum. Slightly acidic is yellow. Green is neutral. Blue is alkaline. And violet or purple is very alkaline. So that's what you need to know. That basically why we're calling it an indicator, because it indicates about what the substance is, whether it's an acid or a base.
It's about
Am I audible to all of you?
Yes, sir.
Okay. So note down these colors. So why we call it indicator? We call it indicator because
सर आपकी वॉइस अभी भी लैग कर रही है.
Just give me a minute. Is it still lagging? Yes, Khatija, is it still lagging? We have started acid bases. And we just discussed about acids and bases. Yes, is my voice is still lagging? Yes, am I audible now?
Yes, sir.
Okay, So universal indicator, why we are calling it indicator? Because it indicates by the color that whether the substance is acid or a base, then further whether it's a strong acid or a weak acid or strong base or a weak base. So you have to remember these colors. If it's a green, then it means the solution, the substance is neutral. If it shows yellow color, then it is slightly acidic or weak acidic. If it's red, then it's a strong acidic or very acidic. If it's blue, then it's slightly alkaline or a weak base. And if it's violet, then it's a strongly alkaline or a strong base. Is this clear?
The light green is also slightly acidic.
No, it's in this, but for Cambridge, we consider yellow as a slightly acidic for universal indicator, okay? That's why I have mentioned the color over here. You have to note down these colors. Yes, Sami and Manahil, is this clear? Yes, everybody noted down this?
सर एक और बार समझा दें, आपकी आवाज बीच में लैग हो रही थी.
Okay. So indicator is the substance which changes the color, and its color will help us to identify the nature of the substance. If we use a universal indicator, if we add universal indicator, if we mix universal indicator with a substance and its color changes red to red, then it means that the substance is or the solution is a strong acid. If the color turns yellow, then it's a weak acid. If the color turns green, then it's neutral. And if the color turns blue, then it's slightly basic. And if the color turns violet, then it's weak, strong base. Is it clear now?
Yes, sir.
Okay. Yes, noted.
The blue is slightly alkaline.
Yeah. Done. Okay. Now, if we talk about the solution, whether solution is acidic or basic, so every solution is present in water. We use water to dissolve a substance, right? So when we dissolve anything in water, so which ions water will form? Yes, Sania? Which ions water will form?
H positive.
H positive, good, and OH negative. So it means in every aqueous solution, these two ions are present. Okay. But the thing is that for any solution, when the amount or the concentration of hydrogen ion is greater than the concentration of hydroxide ion, please focus here. If the condition is this, then that is an acidic solution. Okay. So if the hydrogen ions concentration is greater than hydroxide concentration, then solution is always acidic. And if it's opposite, like hydroxide ions are greater than hydrogen ions, then the solution is basic or alkaline. Okay. Then what is the difference between more acidic and less acidic? We have just decided if the solution is acidic, then it means it have a greater number of hydrogen ions as compared to hydroxide ion. But if the hydrogen ion is in very large quantity, then it is considered as more acidic. And if it is greater but is in not that much large quantity, then they are considered as less acidic. In the same way is for alkaline solution. If their hydroxide ions are relatively in a lesser amount, then it's a less alkaline or weak alkaline. And if it's more alkaline, then it means that there will be a very large concentration of hydroxide ions in the solution. Okay. Okay, complete this. Now, next thing that we are going to discuss is neutralization reaction. So what we know so far that these ions are present in which substance? Acid, and hydroxide ions are present in alkali. Okay. And okay, if the substance have more number of hydrogen ions than hydroxide ion, then we consider that substance as a or that
Acidic.
solution as acidic or acid. And if solution have a lesser number of hydrogen ions as compared to hydroxide ion, then the solution is alkali. Okay. What if the solution have hydrogen ions concentration and the hydroxide ion concentration same?
Neutral.
Then it is neutral. Okay. So basically, when we talk about water, if water is pure, then it is always neutral. Okay. So the neutralization reaction is reaction that occurs between an acid and an alkali, and as a result, water and salt is formed. So why we call it neutralization? Because when acid and alkali reacts, they will cancel out each other's effect and form a substance which is water, and water is a neutral substance. That's why we call it neutralization reaction. Is this understandable to all of you? So remember, a reaction between an acid and an alkali is neutralization, and in this reaction water and salt is formed. So here we have a word equation first. When acid and base reacts, what we will get? Salt and water. And the ionic equation for this kind of a reaction is hydrogen ion, and hydroxide ion always forms water.
So what about salt? What about salt?
Yes, that's what I will tell you. Wait. That is the थोड़ा उधर जाके Okay, so when acid and base reacts, we will get salt and water. When we talk about a base is, as we discussed earlier, a metal oxide and a metal hydroxide, right? So now we are first going to discuss the equation of acids with metal oxide. So when metal oxide and acid. Okay, so when acid and metal oxides react, we will get salt and water. So here, if you see, this is the one acid, which is nitric acid. Then we have a phosphoric acid, and then we have a sulfuric acid. Please sit over there. Then we have metal oxides. In the first reaction, we have a copper oxide. In the second, we have a magnesium oxide. And in the third one, we have a zinc oxide. Okay, first copy it down, then I will show you how to make the equations. Ms. Raga, are you done with the equations? Okay.
State aqueous one.
H2O is liquid. Okay, do remember in these kind of a reaction, the acid is always aqueous. The metal oxide that we are going to use will be solid. The products formed are salt and water, so salt is always aqueous and water is liquid. Yes, everybody done with the equations? Yes?
Yes, sir.
Okay. Now, okay, note down the fourth one. The one equation I am going to show you how we will make it, and the rest of the equations you guys will try, and if you have any confusion in that, you can ask, okay? Now, see, you have to first identify from where the water is formed. So if you look at these equation, what acid produces when it dissolves in water? We did it in last class. Hydrogen ion, right? So this acid is going to produce the hydrogen ion, and the metal oxide is going to give you this oxygen. And what will happen that the two things which I have underlined will join to give you H2O. Okay, now there is a one confusion that students always got confused. How many hydrogen I have put it over here?
One.
Here,
Two.
two. And how many hydrogens are here?
One.
So it doesn't matter how many hydrogens here we have, we are always going to write H2O initially. At the end of the equation, we are going to balance it. For example, if you see over here, how many hydrogens are here? Three. But when I am going to make the equation, what I am going to do? I am going to write H2O again. Okay. Is this point is clear to all of you?
Yes.
So I have noted down H2O. So that H2O is produced from this H and this O. So what is left behind? Copper ion and nitrate ion. So we have to take the help. We have to write them like this. Then we have to identify their charges to make the salt. So what is the charge on nitrate ion?
-1.
-1. Very good, Khatija. Nitrate ion always have a -1 charge. Okay, in these equations, it is easy to recall the charge. If you don't remember it, we discussed it in the last class as well. See how many hydrogen ions are bonded to it. One. So it means it is going to have a -1 charge. How many hydrogens bonded over here?
Three.
So if these three hydrogens will remove, it is going to have a -3 charge. Here, two hydrogens, so it is going to have a -2, and here, so -1. Okay, okay. So we got the charge -1. Okay, copper. What charge copper ion have?
Positive one.
Is it in group 1? Copper ion have +2. In these all equations, these three are going to have a +2 ion, and this one aluminium is going to have a +3 ion. Okay, so I got the charges. Now I'm going to make the formula of the salt. What is the rule for making the salt? the value of the charge, not the chart, the value of the chart is always moved to the subscript of the other ion. For example, if I'm comparing copper and nitrate, so the nitrate have a -1 charge. So one of the -1, the one from -1 move to the subscript of copper, and I know there is no need to write 1 over here. And this 2 from copper is going to move to the subscript of nitrate. So as a result, the formula formed will be CuNO3 twice, because nitrate have two elements, nitrogen and oxygen. So if I move a 2 in the subscript, I have to enclose this in the bracket. If for instance, instead of this, let's suppose there is a Cl. So how many elements it have? 1. So if I'll make the formula, it is going to be CuCl2. There is no need of bracket because there is a ion have one element only. But in this case, as there are two elements in the ion, so when I move the charge for when making the formula, I will enclose it in the square bracket and write 2 below.
Okay.
Is this clear to all of you?
Yes.
Yes, Khatija, Sami, and Manahil.
Yes, sir.
Okay, now if you try to balance the equation, how many hydrogens we have over here?
2.
2. And how many here? 1. So what I will do, I will put a 2 over here. So if I put a 2 over here, this makes these nitrates 2 as well. And here we already have a 2 nitrates. There is a 1 oxygen, 1 copper, and 1 copper. So the equation is balanced. Now try to make the water and salt in these 3 equations, and I will tell you how to balance it. Okay. What I'm going to do, I'm going to just give you the charges now. I have mentioned the charges. So complete these 3 equations quickly. So magnesium have a 2 plus, phosphate have a 3 minus. That's what I am writing over here.
So हमें स्टेट सिंबल लिखेंगे H होगा.
Yes, it is liquid. As I have told you, in these equations, the salt formed is always aqueous and the water formed over here is liquid.
Sir, I have a question.
Yes, Kanika?
Sir, copper is a transition metal, right?
Yeah.
So, sir, how do we know that its charge is +2?
In most of the cases, when copper undergo reaction, it always form a ion with +2. And if it is not forming the ion with a +2 and it is forming the ion with any other charge, then examiner for sure mention that charge.
Okay, sir.
So this is an alkali aqueous water.
No, here the metal oxides are solids. These are all water insoluble.
And it's PPO4.
It's aqueous. All acids are aqueous. In the last class, we have discussed they produces hydrogen ion when dissolved in water. So all acids are aqueous. Are you done with the equations? Yes, Aisha. If any one of you have need any help, please tell me. What is the charge on the support? Two hydrogens. So what will be the formula of this? The three liquids and two things. For the same time, we will put it just as it is. Very good, very good, very good. To a power. It's given, yeah, in the system. And when you move the two from here to here, if there are more than one element, so you close it in bracket and then put two. Put a plus over here. Just right. Okay, now complete. Why you are putting a two plus? We always move the charge, not we value, not the charge. So true, and we also have to move three over here because it have a three minus, right? Yes. So three and two. And three, you and we have a plus two charge. C
+2.
it's in group two. You are so slow. We always put the charge here below. Yeah, now balance it. No, we don't use this ALC. And that is the reference, so you need to do it at the other line, not over here. Because that is fine because you did it below. Not aligned with the equation. Now, can you try to balance these equations? Done? Balanced? Okay, so if you see in all of these equations, one thing that is formed is water. And if you identify how the water is formed, so you can easily mark that the oxygen and these hydrogens are forming water. Is this clear to all of you?
Yes.
Okay. Now if you see, here magnesium have a 2 plus and phosphate have a 3 minus. So when I will make the salt, it will be Mg3 and PO4 twice, and it is going to be aqueous. And here Zn has 2 plus and sulfate has 2 minus. So when the charges are same, we just join them. And here AlCl3 aqueous. Is this clear? Okay, now you have to balance the equations. So if you see, how many magnesium are here? Always start the balancing with the salt. In these equations, in acid-base equations, always do the balancing with the salt. So how many magnesium we have over here? 3. So what I am going to do, I am going to put a 3 over here. So how many oxygens over here now in magnesium oxide? 3. And in water, how many oxygens are there? 1. So I just put a 3 over here. See, the equation is balanced. No, 1 minute. Yeah, the hydrogens are still not balanced. Here we have a 6 hydrogens, so I'm going to put a 2 over here, which balances the hydrogen and the phosphate ion. What about the third equation? Is it balanced or we need to balance it?
It's balanced.
It's balanced, right? Yes. See, we made the water from the hydrogen and the oxide. So the leftover ions makes the salt from the acid and a base. See, acid have 2 ions. One is a hydrogen ion and the other one is the negative ion. and base have a one oxide ion and the other positive ion. So that oxide and hydrogen turns into water, and the ions which left behind, we will put their charges and then make the salt from those ions.
But then we balance the equation.
Yeah, afterwards we will balance the equation. Is this clear to all of you? Okay. Now, if I have to balance the third equation, I'm going to put a 2 over here with aluminium chloride, because in aluminium oxide there are 2 aluminium. Then this 2 makes chlorine 6, so I'm going to put a 6 over here, and then I have to put a 3 before water. Now the equation is balanced. Yes, Laiba, is this clear? Yes, Sami and Khatija, is this clear?
Yes, sir.
Yes, Sania, Aisha, is balancing clear? Okay, now see over here, when we talk about these oxides, so you have to remember their colors. All these oxides are white solid except copper oxide, which is a black solid. And here all the salt solutions found are colorless except copper one, because copper is a transition, so it usually shows you different color. Then is everybody completed?
Yes, sir.
Okay. Now, there are 2 types of bases, right? One are metal oxides and the other one are metal hydroxides. Okay. So when acid reacts with metal hydroxide, again what we are going to get? We are going to get the same products, salt and water. So it doesn't matter whether the acid is reacting with the
Acid or
whether the acid is reacting with the
base or
metal oxide or metal hydroxide, as both are bases. So we are going to get
salt.
salt and water. So here you have a 6 equations,
So you also force the particle.
blue solution. Okay, I'm going to make the last one, and then rest of the one you are going to try. So let's have a look. Okay, we discussed in the last class, if you recall, these ethanoic acid or the carboxylic acids, only the hydrogen which is bonded to O is going to be released as the hydrogen ion, and the rest of the hydrogen stays intact. So this hydrogen and the OH from calcium hydroxide, these two are going to form water. Is this clear? Yes, Sami and Khatija? Okay, now,
Yes, sir.
so if we look at the leftover ion, so here the leftover ion is, one is CH3COO. What will be its charge then?
-1.
-1, very good, because only one hydrogen is released, so it is going to have a -1 charge. Okay, and what is the charge of calcium? As calcium is in group 2,
+2.
+2. Okay, so now if I'm going to make the formula, it is going to be CH3COO, and then I have to move the 2 in the subscript of this, so as there are more than one element, so I'm going to enclose it in bracket and then write the 2 and then Cl. So that is the salt. Now see the difference. In the previous salts, the metal that we have written at the end, we are writing it in the front like this. If you see over here, we made it the Al positive and Cl negative, right? So we write the formula AlCl3, we put the positive ion before, and here we are putting the positive ion at the end. Why is it so? Because if you see the position of hydrogen in these all salts, the hydrogen is before. So that's why when we make the salt, we will put the positive ions in front. And here, if you see in these two acids, the hydrogen is at the end. So when we make the salt, we will put the positive ion at the end only. Is this clear? Okay. So if I balance the equation, there are two CH3COO groups over here. So I'm going to write a 2 over here. And there are two OH ions over here. So it means there are two water will be forming over here. Now, if you see, the equation is balanced. If anyone have any confusion in balancing or in formula making of salt, please ask and try the rest of the one. Or balance.
NaH2
Hmm?
NaH2 positive with it.
Which NaH?
The first one.
The Na is +1.
NaH+.
NaH, why NaH?
Because H2 or O2, whatever.
H and OH makes water, so the leftover is Na plus and SO4 2 negative, right?